everyone. Welcome to talk number 1 for a day of defensive thinking. Glad you're all here. A few notes before we get started. At the back of the room, you'll see a green and red card. This is a chance for you to comment on how you enjoyed the talk. So at the end, please grab a card and drop it in the basket to help us evaluate the talks. I think we're going to start the day off with a really critical and important topic around baking security into frameworks. And Oliver Lavery? Yep, excellent. Oliver Lavery is the VP of Research and Development at Immune.io. He's a software developer, he's a penetration tester, a consultant with over 15 years of experience in the industry. When not coming up with defensive algorithms, Oliver enjoys making kernels involuntary do his bidding, breaking mainframes, and generally causing playful chaos. It's my great honor to introduce Oliver, talk about secure frameworks. Thank you. Thank you.
Hey, thanks a lot. That's quite the intro. So yeah, hi, my name's Oliver, as we know, and I work for this company called Immune.io, and for the past couple of years, we've been trying to figure out ways to really fix the web in a fundamental way, to try to make some of these problems that we've all been dealing with for a long time go away, or at least mitigate them in as far as we can. My background is doing pen testing, and at a certain point you get fed up. You get fed up with constantly reporting the same issues, never seeing them get fixed, and with this tension that you have between developers, the business, and the teams tasked with finding the issues. One minor point, because we are working on a commercial product, this talk does talk about stuff that is closed source, but I think it's really exciting and new, and the research we've been doing is kind of cool, and I wanted to share it with you guys. And unfortunately, when you're a commercial vendor, there's no alternative than to talk about a commercial product. So what's really the fundamental problem with web app security right now, to my mind? It's that, we've come so far with the technology, but we've never found a way to eliminate the threat of humans making mistakes. And humans make mistakes. There's just no two ways about it. So we propose solutions like this. This is from the OWASP sort of guidance about how to escape data. Here's a large table of very complicated rules that you just need to memorize them, follow them every single day, and never ever make mistakes. And then don't worry, you'll be fine. I used to be a consultant and I would teach people this in classes, and you kind of have this odd feeling at the end of the day, like all you've done is sort of rephrase the problem, not actually offer a proper solution. So, we've got issues here like, HTML body, apply entity encoding. Well, that seems fairly straightforward. But then what if we get into some of the harder edge cases? Like CSS. Well, let's just do strict structural validation. Okay, yeah, thanks for that. What's strict structural validation? I need to get back to writing business logic and hack and code to get my job done. Could you please explain that to me? Or when we talk about the HTML body context, things get even crazier. Like, yeah, it's easy. Just, get a validation library and apply it. Pick one of these many and they'll do something magical that'll help you, and you won't have any problems. And as long as we think of the solution like that, we're really just not addressing the root cause of vulnerability on the web. If you take a step back and listen to the various statistics we like to throw around, like 80% of web applications contain cross-site scripting. We've been at this for 10 years now. If that's still true, we're not solving a problem. As much as we want to, and as much as we apply effort to this, the reality is human beings are not good at mechanistically applying a set of very complicated rules perfectly 100% of the time. As long as we predicate the security of the web on the idea that developers have to be infallible, the web won't have any security. It just goes without saying. And what do we do now when things go wrong? Well, we blame the developers. Oh, you need to invest more in SDL. You have to work better. You need to do more QA, more static analysis, more dynamic analysis. Buy a lot of commercial tools from vendors who are sponsoring this conference, so I won't make fun of them. Do better threat modeling. Does this really sound like a sensible solution? But when we look at these technologies, right, they were all designed in a fairly particular way. HTML is not made of magic. It's just a syntax. It's a language. SQL, it's not made of magic either. It's just a language. All of it's machine readable. If only there was some sort of infallible mechanical device that could take these machine-readable languages and apply rules to them. Doesn't that seem like perhaps an easier solution? So we go ahead, and one day we invent WAFs. And they kind of offer some of that solution, but they fall a little bit short, right? Because WAFs are really applying an older infrastructure concept to applications. We're going to take something that is completely disconnected from the application and sitting over here, and we're going to have it try to solve problems in an application over here. Well, that works when you're dealing with protocols like HTTP, IP, TCP, which have very little state, and the WAF can understand that, or a firewall can understand that state easily. But when you're dealing with an application, it has an enormous amount of internal state that the WAF just has no insight into. It's just sitting there trying to blindly apply rules to protocol streams. It's not really a layer 7 solution. It's kind of a layer 6.5 solution. And if you look at sort of the adoption rates and people's experiences with WAFs, you can see that that's sort of the results that we've got. Yeah, they help a bit. They have to have these really complicated rule sets. You have to configure them and customize them to every application. It's just not really a viable approach to a complex problem. So then if the solution isn't web application firewalls, then what is it? I mean, it's almost like all these web applications, if there was only something common about them where we could start to address problems at their root, right? Some kind of common component or element, like, say, the frameworks they're all built on, right? Why don't the frameworks build security in? Or could we build security into the framework itself to try to apply solutions to the root of these problems and prevent developers from having to be magical, infallible people? Can we automate some of it away to make it easier? And when you start thinking about it, really what we're talking about is fixing the foundation of the problem. There's this tower not too far away from here, right? And it started to lean to one side. So the solution that got applied is they built one side taller to compensate as they were going up so that the whole thing wouldn't fall over. And that's kind of what we've been doing to the web. Well, it's really, really, really hard to write web application software in a secure way. So let's invest a huge amount in tools that fix things after the fact instead of just trying to make it easier to write software securely for the web. If we could get rid of all of these like trivial coding errors, cross-site scripting, SQL injection, remote code execution, and deserialization libraries, if we could start clearing some of that away, then we could deal with the real hard problems that require human creativity and intelligence, like authorization and access control, figuring out, who should be accessing what data at what time. That's a problem that requires human insight. Figuring out how to escape HTML should not. So that's kind of what we've been doing. We've been building self-defending frameworks, and I've spent a lot of time in the last couple of years working on XSS, and I want to talk about XSS as kind of an example. So if you look at OWASP guidance, some of it is just use eSAPI, but eSAPI is kind of crappy. It provides a good set of libraries that help people, but all it really is a code implementation of good advice, right? A framework is not the same as an API. A framework is something you build on top of. An API is a component you can blat in and call it, but you still need to know how to call it, when to call it, and you need to know what its shortcomings are and when it's not doing the right thing. It still requires people to figure out which of 9 different data encodings to use, and they're not comprehensive, so you need to find solutions for those other bits. I'm not trying to, tear down the eSAPI project. It has a lot of other real value that it's provided to people as these components, but it's just not actually a solution so much as, a helper. So if we look at all of these modern languages and modern frameworks like Django and Ruby and Python and even Java, they all have a facility for modifying the code of the framework itself. There's no reason you couldn't integrate components of ESAPI, say, or ESAPI-like functionality into the framework at runtime. You load up a piece of code, it uses reflection to understand what the framework's doing, patches it on the fly, and can add additional security controls into a running application. This is something that's actually relatively trivial to write because all of these languages have this kind of construct built in. If we still think in the C world, this was possible, but very challenging. In a language like Python, it's really easy, actually. It's built in. It's something that's just fundamentally supported. And if we do this and we take this approach, then suddenly some application security problems become, well, a little easier at least, and that's something. We have access to the entire state of the app, all of its data structures. Anything that's going on, you can look at, introspect, make decisions on. And that's a really powerful concept that's completely different than being a web application firewall sitting on the wire a mile away, trying to look at inputs and outputs and go, maybe something's bad here, I don't know. You're in the application, you can say, well, hey, this SQL statement looks kind of different. Never seen or 1 = 1 here before. Could something bad be going on? You also don't need to worry about encodings and all of the evasion stuff. A lot of it becomes really easier because you can address problems really at the root, at the moment of execution or the moment of exploitation if something's going wrong. So that's it. I mean, we kind of took this approach that we want to make no code changes to applications because right there you're prohibitive, right? The reality is, as a pen tester for years, reported bugs to people. And every year we'd audit the same applications and see the same bugs. Not because they were hard to fix. We'd give them the fix in the report, and they would never get fixed. Why? Because there was no one there to change the code. There's a cost associated with that. Not all applications are, maintained and kept up to date and have an SDL or even the remotest development budget. We wanted to reduce the impact of the mistakes developers do make and allow them to make those mistakes. Not encourage them, mind you, but make sure that you can have security without infallible humans. And we wanted to make something that was practical to roll out against a large number of applications and kind of deal with them in a coordinated way. And we'll talk about that more a little bit later. So here's basically how you can apply this kind of idea. You could apply it in your own project. It's straightforward. You have your application logic in a typical application stack at the top. Then you've got a framework underneath it, and the framework does a bunch of stuff and usually calls some supporting building block libraries, like Rails has Rake behind it. You have all of the different bits of the library frameworks that do your file access to SQL databases. And all of those things are just functions. You can find those functions, and you can patch them. You can say, whenever this framework is doing SQL-y stuff, tell me. I want to look at it and inspect it. Every time that line of code happens, trap, let me have a look. Then in our world, we added a virtual machine so that we didn't have to do everything separately for every language. Simple enough. We have a piece of common code that goes in and instruments your framework, and a piece of platform-neutral code that we can apply to Rails or Django or Java or anything. So getting back to the concrete, let's fix XSS. XSS is a machine-readable language. You grab into the rendering framework, the rendering pipeline of the framework, you parse the templates it's rendering, and figure out where people are putting data into that template. As you parse it, you determine the context, those rules I showed you before, on the fly. Is this data being put into the body of an HTML document? Is it data being put into an unquoted attribute or a quoted attribute? From that, you can determine the correct escaping function by OWASP's guidance and apply it dynamically to the data as it's rendered. Simple. If you see violations, flag them up. Tell someone. So here's a couple of examples. Works really well, this approach, if you have fairly well-formed HTML. If I see you're putting a URL into a source tag, I go, does it contain quotes? If it contains a quote, then it's going to jump out of this context into another one. So let's escape that quote. And let's tell someone. Same with this alt tag. So we map these to a couple of types of context. Really just, originally, just following OWASP's guidance to the letter. And this gives us a kind of context-aware escaping, right? Because we're able to dynamically determine the first column, we can dynamically apply the third column, fourth column. Now, in practice, we run into a few problems. OWASP's cheat sheet actually elides a lot of the complexity in the web. And this was a fun series of horrifying revelations as we tried to apply this approach. There are a lot of things that are much harder to escape than OWASP makes out. Parameters of URLs, conditional comments, attribute names are a little tricky. Then you get into really, really tricky stuff like CSS and JavaScript, and there is guidance on that, but it's not conclusive. And in the real world, applications put data into all kinds of horrible and unsafe places, but we'll talk about that a bit more later. Now, I just wanted to show you this in action quickly. I canned this the other day. If I can just find the video. Now again, I know this is a commercial product, but that's not the bit I want to show you. So there's a dashboard and some crap. You've seen all those things before. But as we move through here, we'll just grab a test application. And this is the bit that's a bit more interesting. So this test application actually lives over here. Now, just to explain, I'll pause for a second. This is kind of like a webgoat sort of thing. And we're going to throw some attacks against it and just see how this kind of escaping approach can work in reality. So we've built it ourselves. It's an internal test harness that has a number of vulnerabilities built into it. So let's look at one really quickly. Just simple inline injection into an attribute. So we'll whack a script in there. And bang, you get your classic, XSS script alert. Now if we jump back over and turn on this algorithm, the framework gets notified automatically. And if we try the same exploit, nothing happens. Now, what's really happened behind the scenes here is the first time this page was rendered, we parsed it. This is the way I'm describing it. It's very easy. You just need an HTML parser. We figured out where all of the different data was being put into this page and predetermined which context it was in according to OWASP's rules. Then for future renderings, we just go, oh, okay, this data is going into this location. In this case, it's a quoted attribute. Apply these escaping functions to it. It's really straightforward. It's fast. It's simple. And if we jump over here, we can see what the input was, and then what we determined the output should be to render it's safe for a web browser, in green and red. Sorry, let me just get back over to Keynote. So this sounds really great until you try it in the real world. A lot of these approaches do, and they end up being a lot more complicated than you think. Oh, sorry. There we go. Sounds good until you try it in the real world. And then you find people actually write really horrible HTML in practice. So here's an example where things start to go off the rails a bit. Image, and then a whole bunch of stuff in the image tag. Well, what on earth do you do with that, right? How can you properly escape something that could contain like style attributes and event handlers and all? I mean, it just becomes horrible. So we kind of took a look back and went, okay, suddenly this problem is a lot harder than we thought it was. But actually you can generalize it. And OWASP kind of does. Remember when I mentioned like anti-SAMI and stuff? To just what happens when you blat a bunch of HTML right into a web page. This is actually a really common use case. Anytime you have something like a CMS, a job posting site, you often have arbitrary HTML content whacked out there into pages. So how can you do that in a safe way? How can you handle these edge cases that the OWASP guidelines kind of dodge around a little? Well, so the reality is you kind of can. I thought about this for a little while longer. I went, all right, well, the same way the first time you render a web page, you can remember its structure. The first time you see an interpolation into a web page, you can also remember its structure. So you can develop like a dynamic whitelist, if you like. So we look at each interpolation and go, all right, is this a simple thing in a well-known, obvious part of the HTML render? Or is it like a big spew of HTML? If it's a big spew of HTML, what's in it? Does it contain any unusual or potentially dangerous tags? Let's remember that so that we don't, block application functionality in the future. But if that pattern changes, then we know something bad has happened. Then you kind of run into this additional problem. HTML is an absolute mess. It's this layered thing, this sort of hydra we've built over the past 20 years, with all of these sub-languages and bits and bobs and things floating everywhere. We've got JavaScript. JavaScript can be in many different places. It can be in script tags, our classic use case. It can, of course, be in all kinds of different event handlers throughout the entire DOM. It can be in URLs. It can be embedded in CSS. Then you've got CSS, which is kind of fundamental to the web working. How do you address all of these problems? Well, let's take a step back to the original premise here. Why did we invent computer languages? Because computers don't understand human-readable text very well. We came up with these computer languages that are easy for computers to read. So it might sound challenging if you had to do it like tomorrow, but actually it's not that hard to parse JavaScript or hard to parse CSS. That's how the web works. That's what web browsers do. And we can do it too, as part of the rendering pipeline of an application framework. They're just extensions of the same concepts. So let's talk about some of the ways that this stuff breaks, because we've done all kinds of pen testing and learned a lot about really some of the funny edge cases of the web. I don't know if you guys are familiar with the source doc attribute in HTML. This has got to be one of the most appalling extensions to HTML ever invented by man. You can basically specify the HTML as a big blob of escaped goo in the source doc of an iframe. Well, what happens if you have an iframe with a source doc inside the iframe of a source doc, and then put the iframe, another iframe in it? So you end up with this recursive escaping problem that is borderline intractable. I mean, if you want to bypass a WAF, this is probably a reasonably good approach. The nice thing about being in the rendering pipeline, again, though, is that you can actually parse all of this stuff, remove the escapes, recursively evaluate it, and then find out if someone's sticking something nasty like a script tag down deep inside of it. CSS is also one of the most strange and bizarre languages I've ever seen. It's actually pre-processed. So things like escapes or comments that break up bits of CSS don't actually get evaluated when it comes time to evaluate the CSS code itself. So you can say things like expression with *//* in the middle of it, and it still parses just fine. It's a lot like C, where everything was removed by a preprocessor. And that's completely different to how other languages that make up HTML, in a broad sense, work. So not only do we have all these different competing languages to deal with, there's actually competing approaches on how to evaluate and design a language built in, which just ends up being quite horrible. And sometimes HTML parser, like the slide says, is a bit of a generous term. I don't know why this works. It doesn't really make any sense. But hey, it's a bug in the way WebKit seems to work, and it'll actually evaluate as JavaScript, even though it's supposed to be a style tag. Bizarre. So, moving beyond XSS, we started out doing this stuff with SQLi, actually. And the same approach, I think, can be generalized to a huge number of problems with internet technology, or with HTML technologies, with web-based technologies. If you can determine the structure of code, you can see when that structure is changing in a way that would affect how that code is evaluated. The fundamental problem we're really trying to solve is user input, which escapes from the context of data and can become code. Really, these problems are exactly the same problems as Charlie Miller was talking about with native exploitation. Whenever you can cross the boundary between data and instruction, or between data and control, then you have a security vulnerability. So if we can understand the structure of something like SQL, we can look for structural changes that mean a different SQL statement is being evaluated. And if we do that inside frameworks, then we can do it at the granularity of every single SQL statement as it's being called. We can dynamically protect those. We don't need to understand the set of all statements a program makes. We just need to be able to say, this line does this SQL statement. Is it now doing something different? And I think this approach is taking off. So there's a bunch of things we've tried to apply this to and with various degrees of luck. Cross-site scripting, SQL injection, a lot of the older sort of intrusion prevention system ideas like file access and command execution, branching out to shells. It's almost like trying to take these concepts that we applied around 2005 to native code exploitation, like DEP and ASLR, and move them into the frameworks we're building, and move them into the applications we're building, to provide sort of a safety net that prevents exploitation of vulnerabilities. Another neat thing you can do once you're in the framework is you can manage state and coordinate state. So if you think of all of these different things happening as parts of a framework, that's great. But how do you coordinate it? That becomes a central problem. And to do that, you need some sort of centralized server that can maintain the state of all of these different kinds of heuristics. Once you do that, something else happens. You actually are able to begin applying security rules across a wide number of applications and melding them together. So, here's an example. Supposing a threat agent comes to one of your servers and you detect that he's doing something bad, like trying to brute force a password. If you have this kind of centralized control of how all of the agents that make up an application will behave at runtime, then you can understand that that kind of attack is happening and transmit it back to some central point, which can then disseminate it to all of your application servers. Then if that threat agent continues to try to attack them, you can apply something that will prevent him from doing it. So in our case, we see brute force attacks, we can force people to see a CAPTCHA if they hit any application or any application across an estate. Again, trying to make applications defend themselves at a fundamental level, at the framework level. There's a few things we can do once we start doing this sort of centralized management. We can detect a wide array of different attacks and also coordinate analysis of things like people coming in from Tor, people coming in from botnets. If you've seen recently, attack takeover is a huge issue right now. People reusing stolen lists of passwords to brute force into applications. Well, that's the sort of thing that you really want to be able to coordinate across a whole range of applications in an organization. And it's quite easy when you can have a piece of code in all of those applications. So that's kind of the premise of what we've been doing and what I've been working on for the last couple of years. It's really that we have to write good software. We can't stop people from encouraging good software development practices. It's tremendously important, but we also have to realize as security people that writing good software is hard. It's really hard building a web application, and it's really expensive. And we can't rule out mistakes completely. I think we all need to start thinking of ways where we can make applications durable, make them protect themselves, and help developers build secure software without punishment, without it being a difficult and nearly intractable task. I have some more stuff, but let's pause now and I'll ask you guys if you have any questions. Yeah.
On the author of the cheat sheet that you're commenting on.
Sorry.
So when will we see your assistance to add contributions to it to help make it better?
I'd be happy to, honestly. Yeah, I mean, that's why we're talking about this stuff, right? Yeah, we want to share these ideas, not like wrap them up inside commercial barriers. It's ridiculous. Yeah, at the back. Yeah. Yep.
How about performance impact? Since you're intercepting everything, I'd like to know if there's some kind of drawback.
Totally. That's a huge question and a huge problem, right? Obviously, when you're adding functionality, any kind of security functionality, there's going to be a performance impact. And when you're doing it extensively throughout a framework, then it's going to grow. I've tried to address it by optimizing a lot, to be honest. We cache a lot of the results of these things. We use LRU caches throughout to look at all of these different renders and store them. So in benchmarks, we look at about 100 microseconds per page render, plus about 100 microseconds per interpolation in that page. We're kind of aiming to do things in less than 30 milliseconds per response for all kinds of different types of protection. So that's an achievable result. I think we can do better, to be honest. I mean, I'd love to see people try other approaches and find other ways of doing this more efficiently. I think it would be really cool. Yeah.
Wait a second, please.
So I might have misunderstood some of the concept during the talk, so sorry for that up front. But if I understand correctly, the approach, at least for the XSS protection, is that you compare like a known good HTML structure in some sort of like, I don't know, learning phase or during the first rendering of the page.
First rendering, yeah.
And then you try to compare that dynamically during the subsequent renderings of this page. And you know, if the context structure or the HTML structure changes, you might detect that it might be an attack and block it, right?
Yeah.
This is all cool, but it's like totally blind to DOM XSS if you're applying that at the time of rendering the HTML or time of serving the HTML.
Yeah.
So the way I see XSS right now, the XSS attacks that are happening, is a lot of them actually are not the render.start attacks, but more of them increasingly start being DOM XSS attacks, in which the HTML structure changes on a client, and you're blind to that with
Absolutely.
this approach.
No, you're right, we are. And that is an area for more exploration and research, right? I mean, we started with server-based XSS attacks. We do stored and reflected, and it works really quite reasonably well. Yeah, the next area for exploration is going to be DOM-based. It is, the growth of XSS is there. That doesn't mean that the server-side stuff is gone.
Oh, sure.
It's gone in Facebook. It's still a problem for a lot of people. But yeah, no, you're right. We're blind to it, and that is something that needs more exploration.
All right, thanks.
I'd love to see an open source library that really detects it well.
Hey, just want to get your thoughts on other classes of vulnerabilities. So we obviously covered related to injection. You have SQL, you have XSS.
Yeah.
But you know, what about other things, right? Is there something we can do, say, for authentication, for access control at a framework level?
Yeah, absolutely there is. So for authentication, it's really easy, to be honest. I mean, we already do that, and we just hook into the authentication libraries, and we can capture all the authentication events and reinforce them with things like captchas. So if we see lots of failed password attempts, and the framework doesn't have some mitigation for that, then we can add a mitigation. And we can do it across like apps, which is really neat. Another company in the field, I won't name because they're a competitor, but they're doing state chain analysis for things like authorization. It's not something we've addressed yet. It's really neat. But essentially, if you see people follow the same graph through a site, the same sequence of browsing and traversals, you can kind of average all of those together and get a profile of what normal movement through a website looks for, and then look for digressions from that, statistically, to try to do authorization. It's not something I've personally played with, partly because I think it's a harder problem, and we wanted to address only really hard problems, not really, really hard problems initially. But I think it is a really cool place for companies to explore in the future, yeah. Or open source project. Anyone else?
Sorry? Yeah, when you talk about fixing cross-site scripting, especially cross-site scripting on a framework level, wouldn't it be not the most important step to address, to make a framework CSP compatible, so that a framework that, so because you haven't mentioned it in your talk, but wouldn't it be the best way to do that?
Yes.
Right? So
yeah, it would be ideal.
So
it's challenging without changing the application's behavior in any way, right? Yeah. No, go ahead. He's bringing the mic back.
I'm just saying, if you would be able to address it on a framework level, then you perhaps would be able to provide a framework that would be 100% CSP compatible.
Compliant. Yeah.
Right? So that would be just one.
A very good idea. It would be amazing. It's something that we've investigated, but not really.
We see that in frameworks like AngularJS today.
Yeah. Anyone else? No? How much time do we have left? Oh, we're almost there. All right, great. Well, thanks very much, everyone. Appreciate your time.